All right, let's graph some linear equations. We got ourselves an equation in the form y equals mx plus b. And when you have something that's degree 1 and y is already all by itself, the number in front of x is your slope. Now, negative 2 is the same as negative 2 over 1. That's going to be important in a second. First, though, we need to identify what the y-intercept is, and that's the number floating around all by itself when y is alone. So my y-intercept is negative 2, so we're going to put a dot at negative 2 like so on the y-axis. We're then going to use the slope of negative 2 over 1 to make as many dots as we can. Now, a negative slope goes down and to the right. So I can go up 2, left 1, up 2, left 1, up 2, left 1, up 2, left 1. Or if I wanted to go, I could have gone down 2, right 1, down 2, right 1. Now that we are done, we can take a line and draw a line through the dots. And since I'm really bad at drawing lines with these guys, I'm just going to use the magic of the internet to do it for me. Will it give me arrowheads? Yeah, look at that. Oh, wow. Perfect. So we have ourselves a line with a slope of negative 2 and a y-intercept of negative 2. Fun stuff. Graph 32 minus 2x equals 8y. Well, y is not all by itself, so what we have to do is get y all by itself. Now, since 8 is being multiplied to y, I only have one step to do, and that's divide literally both sides by 8, which is literally everything by 8. Literally. That's a sign of a bad vocabulary. So 32 over 8 is 4. Negative 2 over 8 simplifies to negative 2 over 8, which is negative 1/4 x equals y. Now, I hate the way that looks. Y is all by itself, so why don't I write out y over here? And that's going to equal, in order, negative 1/4 x and a plus positive 4. Now we have this in slope-intercept form, which is y equals mx plus b. And when y is all by itself, the number in front of x is going to be your slope, and the number floating around is going to be your y-intercept. So always start out with your y-intercept, which is 4 on the y-axis. This is a negative slope, which is going down and to the right. So use that slope to make more dots. So I can go down 1, right 4. Can I do it again? No, not enough space. But if I can go down 1, right 4, I can go up 1, left 4, like so. Now that I have enough dots drawn out, I could take my line and I can draw a line that connects through the dots. I think that ought to do it. Let's use this little guy over here to make myself some arrowheads. And yeah, that's me graphing a line. Fun stuff. Graph 0 equals x plus 1/4 y plus a half. Now, in order for me to graph, I really want to get y all by itself. There's a couple of options here. What's really annoying the heck out of me, though, is the fact that there's a 1/4 living in front of y. I want to get rid of it. So what I'm going to do first is multiply both sides by 4, and that'll allow me to cancel out the 1/4 using 4. Here's really difficult stuff. 4 times 0, 0. Distribute the 4 to everything, so 4x, 1/4 y times 4 is going to be positive y, and that's going to be plus half of 4, which is 2. Now let's remove everything and get y all by itself. So we'll subtract 4x from both sides. And while we're at it, let's subtract 2 from both sides, like so. That leaves us with negative 4x minus 2 equals y. Now that y is all by itself, tell you what, I don't like it. Let me flip-flop things around. Y equals negative 4x minus 2. Now that y is all by itself in a position that I enjoy, I can compare this to y equals mx plus b. Now, this is slope-intercept form, which means when y is all by itself, the number floating around in front of x is going to be my slope. So my slope is negative 4, or negative 4 over 1. My y-intercept is negative 2, and that's where I'm going to begin. So put a dot on the y-axis where negative 2 is, and let's use that negative 4 over 1 to make more dots. Now, negative 4 over 1 is a negative slope, goes down and to the right. So I can go up 4, left 1, up 1, 2, 3, 4, left 1. Can I do it again? Yep, 1, 2, 3, 4, left 1. And if I want to put more dots, I can go down 4, 1, 2, 3, 4, right 1, and put a dot right there. Connect the dots like that, using this magical line that I have already waiting for me and stuff like that. Let's do a better job. Let's make some arrowheads, and just like that, straight line going through my dots. Bada bing! Graph x equals -1. If you are being asked to graph x equals a number, it's going to be a vertical line going through that number on the x-axis. So let's go to the x-axis. Let's label -1. Let's go pull up our line, put it where it needs to be, like that, nice and vertical. Let's scooch it over just a little bit. Let's add some arrowheads, and we are good to go. That's it. Pretty simple problem. Write the standard form of the equation of each line, or this line, given the slope and y-intercept. Well, my slope is -3/5, my y-intercept is 5. So let's do this. Let's write this out in slope-intercept form, which is y equals mx plus b. If my slope is -3/5 and my y-intercept is 5, we have y equals -3/5 x plus 5. Now my job is to get this into standard form. Standard form looks like ax plus by equals c, where I'm not allowed to have any fractions. So what I might want to do first is get rid of that fraction. How do I get rid of a fraction where something is over 5? Well, multiply both sides by 5, of course. So 5 times y is 5y. 5 times -3/5 x is going to be -3, because the fifths and the 5 cancel out. And then 5 times 5 is 25. Now, in order to get that -3x from the right side to the left side, I'm going to add 3x to both sides, like so. The 3x and the 5y on the left don't combine. 3x plus 5y is going to equal 25. And that is your answer in standard form, baby. Write the standard form of the equation of this line right here. Well, it looks like it's some kind of weird version of point-slope form, because it is. So maybe what I'll do is I'll distribute that negative first, so we get y plus 1 equals -x minus 3. Now, let's do this. In order to make it standard form is in the form ax plus by equals c, no fractions allowed. So maybe what I'd want to do first is get rid of that 1 on the left. Not that that has to be the first thing, but I don't know, it just makes it look better. Y equals -x minus 4. And let's move that x to the left by adding x to both sides. So add x, and that leaves you with x plus y equals -4. That is the worst equal sign in my entire career. But you saw it, and I'm leaving it, not editing a thing. But that technically is standard form. So there you have it. Gross, but fine. Write the standard form of the equation of the line that goes through the given points, -3, 2, and 0, -1. I think probably the easiest way to do this, because I want standard form, I think the easiest way to do this is start out with point-slope form. And once I get point-slope form, I can turn it into standard form. So what's point-slope form? Point-slope form is y minus y sub 1 equals m times a quantity x minus x sub 1. All right, you're going to label your points x sub 1, y sub 1, x sub 2, y sub 2. Now, before I even do anything, I need the slope. I don't have the slope yet. So the slope formula is m equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Y sub 2 is -1 according to what I labeled, minus y sub 1 is 2, all over x sub 2 is 0, minus x sub 1, which is -3. So -1 minus 2 is -3, And 0 double negative becomes 0 plus 3. So negative 3 over 3 is negative 1. So my slope is negative 1. So now I could start putting this together. Okay, my slope is negative 1. I already labeled u x sub 1, y sub 1, so let's keep it. So I have y minus y sub 1, which I labeled 2, equals m, which is negative 1, times the quantity x minus negative 3. So there's a double negative here. Let's make that a positive. And now my job is to make this standard form. Standard form looks like ax plus by equals c. So basically what I have to do is I have to do a little bit of math, move the x and the y to the left and the regular numbers to the right. So let's distribute that negative 1 first. Right, so that gives us negative x minus 3 on the right and y minus 2 on the left. I need to move the x and I need to move the negative 2, so it doesn't matter the order. Let's add 2 to both sides. Let's just get rid of that. So I have y equals negative x minus 1. And let's add x to both sides. Add x to both sides, cross u out. A positive x and a positive y is going to give me x plus y on the left equals negative 1 on the right. So technically, that's standard form. Is it pretty? Nah. But is it legal? Sure. Write the standard form of the equation of the line described through negative 2, 4, and parallel to y equals negative 3 over 2x plus 3. So I have information about a point, which I'll label x sub 1, y sub 1, and I can find out that if a line is parallel to that guy, this guy and that guy are going to have the same slope. So why don't we do point slope form and use that to turn that into standard form. So point slope form is y minus y sub 1 equals m times the quantity x minus x sub 1. If something is parallel, that means they share the same slope. So my m is negative 3 over 2. I have u labeled. So y minus 4 equals negative 3 over 2 x minus negative 2. So we have a double negative here. Let's make it positive. And now it's a matter of making this standard form. Standard form is ax plus by equals c, no fractions allowed. So what I'll do is I guess I'll multiply everything by not everything, but the right side, distribute negative 3 over 2, so the left side doesn't change. The right side is negative 3 over 2x, and then negative 3 over 2 times positive 2 is going to be negative 3. Now again, fractions are bad. So what I can do right now is I can multiply everything by 2, and that'll eliminate the 2 denominator right there. Okay, so this becomes 2y minus 8. This becomes 2 times negative 3 over 2 is going to be negative 3. X comes along for the ride. Negative 3 times 2 is negative 6. So in really no particular order, I have to move negative 3x to the left and a negative 8 to the right. So let's add 8 to both sides, cross u out. Let's rewrite u up here where I have a little bit more space. So 2y, okay, 2y equals negative 3x, and then negative 6 plus 8 is 2. My last step is to add 3x to both sides, like so. 3x and 2y don't combine, so 3x plus 2y equals 2. So now that's in the form of x plus by equals c, no fractions, x and y are on the left, numbers on the right, everybody wins. Graph the absolute value of x minus 2. Now, this is what we want to do with absolute values. If you want to make a table, you can make a table, but I'm not going to. If you need to see tables made for these types of problems, go back to my Algebra 1 series and do it that way. Okay, y equals the absolute value of x is a v with slopes of negative 1 and positive 1 and starting at 0, 0. That's supposed to be a 0. That was not an accidental inclination as to what's about to happen, except that it was. Because if I were to subtract a number inside the absolute value with x, that is a shift to the right 2 units. So this is going to be that v, but instead of starting at 0, 0, I'm starting at 2, 0. And I'm still going to have my two lines with slopes of 1 and -1. So let me do that. Let me make a line that way. Slopes of 1 and -1 like that. And let's do the same thing over here. Put my line there, slopes of 1 and -1, so there's my 1. What I'll do so as to not make a mistake is I'll draw the arrowheads on this one like that. And you have yourself your absolute value equation with a transformation shifted to the right 2. Wasn't that fun? Y equals -2 times the absolute value of 2x plus 2, close it, plus 4. We need to graph that guy. All right. One of the things that we're allowed to do with absolute values that you're not really supposed to do, but you are allowed to do, is I notice some magic happening inside the absolute value. What I'm allowed to do is I'm allowed to factor that 2 out, which is what I'm about to do, right? So it looks like this. And I'm allowed to bring out the positive version of that number. So I can bring out positive 2, making this -4 times the absolute value of x plus 1, close it, add 4. Now what we have is we have an absolute value with 4 actual transformations going on. Transformation number 1 is I know absolute values look like V's. However, this won't. This is going to be upside down because the negative number makes it upside down to start. Not only is it upside down, the slope is going to be a positive or -4, which is also the same as 4 over 1. Since I'm adding 1 inside the absolute value, I shift 1 to the left, and since the 4 is being added outside the absolute value, I go up 4. So drawing this out is going to have me starting from 0, 0 and putting a dot at -1, positive 4, like so. Then I'm going to have an upside down V with slopes of 4. So I can go down 2, left 4, down 2. I'm sorry, down 4, left 1. I don't know why I said it that way. Or I can go down 4, right 1, down 4, right 1. Okay. Take your lines, which I'm about to do. Bang. Draw your lines going through the dots, and that ought to do it. So, there you go. Yeah. Now you could have made a table or a chart or whatever, but who wants to do that? Graph y is less than or equal to -1/3 x plus 1. This is an inequality, and with inequalities, you're looking at two things out of the ordinary. First off, what type of line do you have? Is it solid or dashed? And second, where do you shade? Well, first things first, this is already y all by itself, so I could treat this like y equals mx plus b, where m is the number in front of x, right? So my slope is -1/3, and b is the y-intercept, which means you put a dot at 1. Now put a dot at 1, and then make more dots by going up 1, left 3, up 1, left 3, or if you run out of space, you can go down 1, right 3, down 1, right 3. Now this is where things change a little bit. This is a less than or equal to sign. Now, if it's less than or equal to, two things change, okay? You're going to have a solid line because it's or equal to, and you're going to shade below because it's less than. So I'm going to draw my line. I'm not going to change it because it's going to be or equal to, so it's still going to be solid. So let's make our line nice and solid. Looks like that. Let's give me my arrows. Let's give me my arrows. Pretty, pretty, pretty. And I'm going to shade below the line. So let me get a bigger pen. We're gonna need a bigger pen, like the Jaws movie when he said, we're gonna need a bigger boat. We're gonna need a bigger boat." He said, "Remember that? The shark movie." Use this time right now to comment your favorite shark movie. Perhaps it's Jaws. Perhaps it's Deep Blue Sea. Perhaps it's Sharknado. Or the Meg. Or the Meg 2. or Jaws 2, or Shark's Tale, or others. And we're done. Well, thanks for watching. That was a lot of fun. But anyway, the point of that is, yeah, graph like normal, solid line, shade below. And all of these dots are possible solutions to that inequality. So, like, what this does is this gives us a shaded region where, again, all of the dots included in the shaded region are possible answers to this inequality. So if I were to plug in 0, 0 into the inequality, I get 0 is less than or equal to 0 plus 1, which is 0 is less than or equal to 1, which is true. So that's what we're doing here. Graph the inequality y is less than 6x plus 1. Well, with inequalities, you start graphing it out like normal, but there's two things we have to keep in mind. Now, before we even get to that, I noticed y is all by itself. So I'm going to say that when y is all by itself, the number in front of x is my slope. So my slope is 6 or positive 6 over 1. My y-intercept is going to be the number floating around. So let's make a bunch of dots. Start out at 1, boom, and I can go up 1, 2, 3, 4, 5, up, ran out of room. I can go down 1, 2, 3, 4, 5, 6, left 1. Now I only have 2 dots that I can draw here, no big deal. Now this is a less than symbol. When you have a less than symbol, you have two things going on. First off, it's a dashed line. And second, you're going to shade below the line. So let's go over here. Let's change this line into a dashed line. We'll select you, you're pretty. And we'll graph these, or we'll connect these two dots like so. So bada bing. So there's my line. And I'm going to shade below it, okay, which is going to appear underneath, which is not, this doesn't seem too much underneath, but imagine if this was a mountain, where's above the mountain, where's below the mountain, or the mountain. This is the mountain. So I'm shading below the mountain. Use this time to comment the word mountain. Perhaps name your favorite mountain. Maybe it's Everest. Maybe it's the big scary guy from Game of Thrones. He was the mountain. He was a bad person in the show. He was a really bad person in the show. Bad guy. St. Helen, that's a mountain. All right. Now, what this shaded region means, what this shaded represents is any of these dots that live in the shaded region is a possible solution, as long as it's not on the line, because you're not allowed to include the line. So if I were to take 0, 0, which lives in the shaded region, plug it in, I would get 0 is less than 1, which is a true statement. Any dot over here and in its extended plane universe is going to be a possible solution. So that is how you do that. Determine whether the given equation represents a direct variation or inverse variation. Direct variation is something that can be written in the form y equals kx. Inverse variation is something that can be written in the form y equals k over x. So which one are you? Well, you are inverse because technically I can write this out as y equals 13 over 12 over x. So this one right here is inverse variation. You are direct variation because what I can do is I can add 5x to both sides, and now your y equals 5x, and you're in the form y equals kx, so you are direct variation. I don't know why I wrote out variation over here but didn't do it over here, but I'm leaving it. Find the constant of variation. Well, this is direct variation, which is in the form y equals kx. The constant of variation is the k. So in this case, k is 3/5, which means the constant of variation is 3/5. Well, thanks for watching, everybody. Like and subscribe. Solve each problem involving direct or inverse variation. So if y varies inversely as x and y equals 8 when x equals 5, find y when x equals 4. Y varies inversely as x means y equals k over x because that's inverse variation. What I need to do is I need to find out what k is by using these guys first to find k. So if y is 8, I'm going to replace y with 8, And if x is 5, I'm going to replace x with 5. In order to get k all by itself, we multiply both sides by 5, and k is going to equal 40. So now I have the equation y equals 40 over x. What is y when x is 4? Well, y is going to be 40 over 4, which simplifies to 10. And there you have it.